Hello. Oh, wrong button. There you go. Welcome back to ABI-DOS. Yeah. Okay. Wait. Hold on. Where's the music? There it is. Last episode, I think it was the second part where we tried to work on altitude plotter. We got pretty close. We got, I think we got both the color chart and the other one. Hello. Yeah, color chart and the one. So based on the color, we can determine this. There were better designs from what I remember. I saw some better designs. I saw out there they used these nullifiers that would rather than I don't actually know the exact details. The nullifiers they would all come out at the same time, and the nullifiers would remove all these colors. So like there will be a nullifier under here, but I guess okay. That's gonna be basically the same idea though. This is about as good as it gets, I think, in terms of producing the right colors. Okay. This time I'm gonna redo this. Now I was thinking that we could have these guys sort of right, what I remember was I had one thing come out for the checker, and then we would go through a series of checks which is the greater value. But I think that the mistake I made was assuming that each one of these needed their own checker, but I don't think that's true. I think you only need one. I think in total you only need one checker for all three. All three of them could definitely just pass through the same checker against this. It would just need to be you just need 3 copies basically. Yeah, you would just need 3 copies. Of the output, which is the 26, the 2. But that is very much duplicatable, as we will duplicate essentially. We'll eventually duplicate anyway. So yeah, I'm gonna put this down in the corner, and then we'll try and rig that up. By that I mean a way of distributing all 3 of these, or like sending all 3 of these into the same checker. Like, because they all kind of have to be written like that, they all have components that must be written, right? It's a lot less clean to get them all together. I guess like ideally you put the input in the middle, and then they all converge, right? Like that's ideally what happens. So something like this, and then the output will be the larger value, right? I mean, I guess that makes sense. Also, like, I can definitely make this a lot cleaner by just shifting everything together like this. The writer's gonna have to like swap positions a bit, but I don't think that really matters too much. So like this should still work out perfectly, I think. Right? All the writing should still come out really, really early. In fact, the earlier the better, because the checking happens afterwards. So yeah. You have this sort of thing. The deal is that they can't all come in at the same time. If you have multiple checks coming in at the same time, right, then they'll all be mixed together. So I think what I'll do is I'll add like timers here. So maybe one will hold for about, I don't know, 20 cycles, the other will hold for like 40 cycles, and then depending on the amount of time we take, it should not be too much. Yeah, it really shouldn't be too much, but because the time it takes for one check is really not that long. It takes like, I don't know, 5 to 6 cycles per check. The issue is timing the check and the input with the new thing, with the these things here. So like, okay, I believe that this is actually somewhat decent. Like, even better if I can do something like this, I think. I guess I'll switch these guys. And then we'll have these guys wait. This can wait 20 cycles, this can wait 20 cycles before waiting the second set of 20 cycles. And so on and so forth, and the input can just come in here. The difficulty now is to create multiple copies of it. We only need 2 copies because there will only be 3 things that we checked. How do I make 2 copies? Well, I mean, it's not that difficult. I can just use a space up here, right? I duplicate once. One of them will go in. They'll all do the exact same thing. They all go downwards. One of them will, so it will look like this, I think. So one of them will pass through here and go down. The other one will come up here and wait here for 20 cycles. The third one will wait. Right, so yeah, this will produce the, this will make sure everything basically times itself somewhat correctly. I mean, I don't know how much time I need here. Let's put like 3 cycles just to be completely safe. It's possible if I just completely remove this. I want to check how long it takes for this and this to sync up. So this is a lot faster, right? 1, 2, 3, 4, 5, 6. This is 6 faster. So I do have to add like, this has to be a 10, I think. So you get this, you get this. Wait, this is faster now. Oh, okay, then this should be a 9 then. Because now we're no longer working with sensors, we actually do have to Wait, are we still doing this? Wait, are they coming out at the same time? They should be. They are not, but it's close enough. It works, I think. No, it shouldn't. It doesn't work because... Yeah, it doesn't work. It has to be exactly on cue. Because immediately after this comes a conveyor that will actually be decided by this bit. So they have to come out downwards at the same time. So like this has to be forced. Yeah. Okay. So let's say that's all settled. Oops. Right. What happens to the 2 next bits? See, the thing is that they will always be tested and they will always be larger than whatever comes out on the other side, because whatever comes on the other side oh, it doesn't matter. It's gonna be a 0. So instead, what if this happened and then like these conveyors also activated a trash chute here? Like this one links to the furthest one, right? So this one will activate a conveyor to the furthest one that would throw it away. Seems okay. Or it would activate a nullifier. I don't know what a nullifier would do, honestly. A nullifier wouldn't help me much. Yeah. But you get the idea. Okay, let's check on something that actually produces a lot of differences. So the 26 produces a difference with the 19 only, but what about this 28? This 28 is very big, it's 150. And will produce differences in all 3. So you get a 3 here, a 3 here, and a 3 here. So you get one that matches first. The 3 is a larger value, which is why it comes out. Oh, what the heck? Oh, this comes a lot earlier, so it can't be held for just 20 turns. It should probably not be held for this long anyway. How about 6 cycles? 6 cycles here, and because this is slightly faster, we'll put a bit more cycles into this, maybe 10. Just spitballing the number here. And we'll wait until the 31 comes out. So now we can do the official checking. So first check comes out. This is still too fast, so how about 12? Okay. Okay, this has to be a lot faster then. I guess there's a lot of extra steps coming out here, so this should instead be, I think these sum by 6, right? Plus another 2 steps. So if I push this down to a 3, do I need to push it down to a 3? Oh, it should be even less than a 3, like a 2. Okay, just hold on for a bit while I work this out. Why is it up? I forgot to change its direction. Again, give me a couple to work it out. Check, check. And then... perfect, check. Wow, it actually works very well. For some reason, the numbers just work out exactly. Of course, when the whole layout changes, I have to change numbers as well. But it should be fine. Right? Yeah, it should be fine. Okay. So, okay. So let's say the output goes here. This is the largest value. I've set this to... so this turns right by default, but the conveyor by default turns it left. When this is activated, it will turn right. So this is the same as pushing the thing down in the previous setup. So there's the exact same thing. I would now like... well, this is the larger value, right? So if this is the larger value, you'll always get 1, 2, 3, 4, or 17 if it turns out to be white. So like, let's say I go to 14 first. So this will check, there's a 170 coming out, I think. Yeah, so 17, 17, and 0 because... what? Where's that 0 coming from? Where's that 0 coming from? How does it check? It checks this value. It checks the 12, which... the 12 wraps around and goes backward, that's why. Then it checks the... it checks that, the 806. Okay. What about the last one? Where's the last one checking? Checks that? Why does it check that? Oh, wait, what? Really? Oh, okay, I see why. Because when it wraps around back, it goes up by 1. And then the next 2 measurements will also go up by 1. Ew. Okay. Maybe it's better if I went up north first. Then right, then down. Right? So rather than going back by 1, the back by 1 always has to happen. So rather than going back by 1 again twice for like this 12 over here, I go up. What if I went up twice? What happens if I went up twice? Would I go here? Would I go to 806? Would I go to 806? If that's the case, that might be a problem. Okay, let's try going up twice. Let's try doing this and seeing where it lands. Goes up and up again. Nope, it goes to 808. Wait, but it's supposed to go to 807. So that wraps it around. Huh? Okay, let's do another check. What if I were here at 794? And then I went down by 2. Would I go backwards? So I go back by 1. I am at 794. If I go down by 2, I'm expecting what? To go back to 0? No, I go forward as well. Why do I go forward in both directions? Does it matter? No. But it really does matter. Because this is the edge case. One other thing I can do is rather than going up, I go down. This is going to be a lot longer because these steps are a lot further to get back from. But if I went here, if I went to the bottom 3 instead of the top 3, there will never be any... There might be issues with this 13, I think. Okay, so maybe it's no longer, maybe I can't do directions anymore as there's a wraparound. Maybe I have to do coordinate values. So like this 22, so like if I went from 26, right, I have to go here, here, and here. I have to subtract 2. Subtract 2. Subtract 26, huh? And then sum 2. Or subtract 26, sub 2, and then add 26. But there will still be a wrapping around, isn't it? There will still be a wrapping around. But yeah, no, the problem is that... Okay, let's say we did in fact look at the bottom 3, like the bottom, the right, and the bottom right. It works for the 22, it works for the 19, it works for everything up to 15 here. For this 13 though, the bottom is safe. The right and the bottom right are not safe. The right and the bottom right actually become, I think, the 28 here, position 28, and position 52, which are not in the same column as it. And how will I know? This puts a massive wrench in our works. Because everything works for like every other value except the edge cases, the literal edge cases. I really don't want to. How did other people overcome this issue? How did they overcome this issue? I don't see how they could have, like, at all. So like, if I read a 42 into here, yeah, the 42 is just wrong. Like, I'm pretty sure it's just completely wrong now. I don't remember exactly how these work, but I forget if it's possible to override. Maybe it's not. Maybe it's fine, regardless. Maybe I cannot override. I forgot the last one. I think inertial simulator was the first one to introduce this idea. The input port will only input values from the original signal state. The input port only. Oh no, it's not. It's not. This one says that if you rewrite a value and read that value, it will still come out as the original, which seems to be maybe okay, but I don't know if I'm allowed to overwrite values or not. I don't think we've ever had that issue before. So I went down instead. I should go right this time. Left, I mean. See, if I go left twice, the issue is I just go all the way back to the next. I go into the 12. Why? Please don't make me. Don't. Yeah, looping the screen, bypassing any looping restrictions, right? It won't work. Like, if this 17 went back twice, it would just hit the 19, which is good. I wanted to hit the 19, but this 22 will hit that, and then after hitting that, it's still not going to work. Because then it hits the third. At the 12, even though it should be 1 down, it now goes up by 2, which will bring up here and then over by 1. Which is 2 above the expected positions I'm looking for, I think. Is it 2 or is it 2? Is it a lot more than 2? Wait, isn't this a lot more than 2? I'm looking for... Wait, what? Did I read this wrong? Hold on. Wait. I get 42. Let's just... Wait, this reads the 26. And then the 22 and then the 19, right? Is there so many loop arounds that it just confuses me? Because this reads to 12, which is up there. So we're 1 up now. If it goes up by 1, oh, it goes up by 1, it would theoretically have been here, but because it loops forward, it loops to this position. That looping shouldn't happen. And then it goes up again. So by right, that signal should have been all the way down here, I think, which makes the most sense to me. Okay. I don't remember that being how that worked, but I mean, sure. We might have to go coordinate numbers here. I forget what if the coordinate number was negative. Yeah, it stays at 0. Staying at 0 is fine. But not fine for something like 13, because 13 will wrap around. I don't like the wraparound. Why? But how do I fix that problem? It just seems impossible to make a machine that... Like, okay, perhaps I have to start from... But no. See, if I start from 26, I'm missing out on things. I'm missing out on the 1926 interaction. That will never get sorted out. Everything else gets sorted out, honestly. Like, literally everything else. Well, no, I'm also missing out the 1922 interaction. Every interaction that occurs primarily in the first row and the first column, they all get missed out. If I just started from 26. If I started from 26, then every number from 26 down to this value are fine. Because those don't loop. Right, in this rectangle, everything's fine. Do I have the edge case for all of these? Even then, that's so many edge cases. Don't worry, let's try and integrate. Okay, let's start from 42 first. Let's start from this 26 value. So we'll get all the necessary values. We get out the expected larger values, which are these. So I think if we started from 26, we'd be basically done with all the data collection and all the things. The only thing we wouldn't be done with is the extra things that come out. The extra things that come out, right, I feel like I should be able to just get rid of. Okay. So let's do this and I set this to a 4. So it takes 2 steps extra. I want the recycling to be in here. I want that to be conveyors. These conveyors are not going to be in sync like whatsoever. They'll be off by default, but they'll be turned on by these guys. This bottom one in particular will be the one that's here. So this will turn this off, while this... Well, it's going to take out a lot of space, but let's assume we have set space. That will turn this on. Yeah, so we get the 2. We get the first 2. And the only 2. Seems okay. Seems very okay. We got other stuff to do though. Like... Yeah, we got other stuff to do. So I realized that this is overlapping a little bit. Wait, this shouldn't overlap at all. There you go. That's slightly better. Still not good. Still not good enough. Okay, so let's instead try this. Does it work? Doesn't look like it works. I don't think it works. Okay, let's not. Let's just accept this as it is. We still have more stuff to do. I need to make sure that when the time comes for I see how the nullifiers can. No, I do not see how the nullifiers can work. Nullifiers can work in better ways. Can they? Yes, a nullifier can work in better ways. If these are ever on, right, they'll never come through, which means that the only thing coming through is this. And if it were the only thing that's coming through, then whatever value it holds will be the bigger value. No, it won't. No, because this will be tested against this value. So it will still get thrown away if it happens to be smaller than this value. Like if this were a 3 and these were like 2s and they get thrown out, they'll be thrown out here. I was trying to make them 0s so that when they come out they'll become 0s and then they'll be sent through. But that's not gonna work. You know, unless I added nullifiers to them. In fact, if I did add nullifiers to them, that would help a lot, I think. But if I added nullifiers to them, the nullifiers do have to be after the weighting. Which I think might be the weird part. Right? So like after the weighting can be put anywhere along this line, but after the weighting, the nullifier has to take place. The nullifier will initially be turned off, but will be turned on afterwards. And what this nullifier will do is it basically just ignores this conveyor down here. No. Wait, no, we're not done. Are we done? I don't even know what we want to do. Let's go back. Push everything back to its previous state. That worked better. How do we deal with empty values? Empty values shouldn't just be like thrown away, right? They should become things. Like yeah, I mean, why not take those values and just shove them in as 0s, because they will be checked as 0s, right? No, they won't be checked as 0s. This will write them down, so they have to be equal to 0. They have to be defined as 0. That's fine. I guess it can be pulled through. I'm not sure if this will mess up with the wiring, but let's hope it won't. And then they'll just come in as regular 0s to take place of the other guys. So let's see if this messes anything up. In particular, I want to find one where the middle one stops working but the end one does work. I think it's fine. So the middle one will be the corner. I want to find one where the corner doesn't work but the one on the left. That should be really easy. I think that, not the 23. The 12 here. So 384. So 384, we'll check against 9. We'll check against 9. So this works, this doesn't work. I'm hoping they don't clash. They don't clash, which is good. It's the only feasible case in which they clash, to be fully honest. Oh, I kind of realized that I also have to build the exact same machine here. Okay, so I think it might be better if I pull this all the way back by 1. I should have enough space for it though. The numbers are definitely going to be changed a bit, but it should be fine. I'm basically pulling off the exact same trick. Yeah. So here again, so Yeah, the ones and the ones will come out as zeros. Just ignore this, will become a zero eventually. Yeah, so these are off by 2, right? If they're off by 2, can I just delete 2 from both? I don't know if that's a valid thing I can do. Wait, but this is faster by 2. I have to add 2 to both. Oops. That's probably better, I think. Actually, I'm not entirely sure. It might be not good for the first one. It's not good for the first one. The first one has to be... Okay, so back to the original values. This one is the one that has to be added to... has to have 2 added to it. Yep. Yep, that's fair. Yep, that's fair. Yep, that's fair. Okay, and then we have the last one here. Would have... Yeah, okay, so there you go. That's... I guess that's that. And then all the zeros that come out will kind of... they'll be timed again, and then things come out. See, the problem is that I'm still not done yet. Like, this could work for everything except the first row and column. I don't know how to fix it. I just don't know how I would fix it. I kind of want to push it off because, like... I suppose you could also say that if it sees a 0, it has to be wrong. Right? If it sees a 0 or anything that's not in... that is not 1, 2, 3, or 4, then it has to be a failed value. It just has... No. Yeah. Yes? If something is not 1, 2, 3, or 4, it's a failed value. Unless it's one of these. See... No. Wait. I'm tripping. If it's not 1, 2, 3, or 4... Well, no, yes, because whatever comes out here is the 10th digit. The 10th digit will always be 1, 2, 3, or 4. So we always get a 17, a 0, 1, 2, 3, or 4. And that 1, 2, 3, or 4 might actually be wrong because you might accidentally read this. So, okay, let's check a random number. Let's try position 24. Alright, and see what that has to show us. So, position 24, what values will you give us today? You'll give us 1 for the 15. You give us a 17 for whatever's down here. And then you give us another 17. So that looks good. That looks good. You gave us the right values. Probably from the wrong positions, but you gave us the right values. What if I went a little further back? What if I went to position 20? So you give us a 1 here from 17, which makes sense. You give us a 170 from here and another 170. So maybe the entire row is fine. I kind of forget what you gave us from this 22, which is position 14, right? It gave me a 17, a 17, and a 0. The 0 coming from a gap in here. It didn't give me a random number, right? Maybe I can say that... Yes. Maybe I can say that. Because it wraps around the back, its phasing is off by 1, its parity is off by 1. So like, let's say I try with another number here. Let's say I try position 352, which corresponds to, I believe, this 16. So this gives me a 1 for the... Okay, no, the 1's from the 16 itself. It will give me a 170 from 17 from the pixel behind. It will then give me... Aha! It gives me a 21. And that 21... No, but that 21 is correct. That 21 is supposed to match with the 16 here. Right? Yeah, it is. So quite clearly, this value works. So we know all rows work, we know all columns work. The 22 also works, but we just have to check for 0 at the very end. Meaning they all work, regardless, right? They certainly don't give us the correct values from the correct positions, but they give us the correct values because there are just so many 170s out there that they are bound to accidentally hit the correct one. So I guess it's fine. I just need to make sure I check for certain values. Like a 0 has to give you a 0. No, a 0 gives you a 17. Yes. Because the 0 only comes with the 22 and the 22 will have a 17 above it. So the 0 must give you the 17. The 0 gives you the same result as 17. Okay, can we agree that that's all settled because I don't want to touch that problem anymore? I would like to time these guys to all sync up with this. So how do I want to time these positions? Probably I want to use this guy. So instead of being thrown away, it's actually going to wait for very, very long, maybe 100 cycles. So let's go back to 42. Our usual answer to life, universe, and everything. Our favorite number to check things on. 42 will read everything but 19. So after a certain point, I want to be able to sync up the input from the color chart with the movement of the pointer according to this bit. And I suppose we will start at this position. The first thing that's going to come out is definitely the one that checks with the 19, which is the 1 and the 2. Then these two will, they'll do their own thing. Wait, didn't these the guys are supposed to be thrown away? Yeah, this I got these zeros to come out because I want to throw these guys away. Oh, so okay, so okay, question. Do nullifiers ignore trash? So let's say I nullify it here. Do they ignore trash? They do ignore trash, wow. So this can activate this nullifier and then it will actually go in the trash. Decent. Okay, so rather than putting the trash here, I could actually put... So what I can do is I can shift this setup up by 1. Trash should be here. Wait, we have some issues, don't we? Kind of, a little bit. If I pull everything out by 1, it should be fine. The thing is, each of these will be going 1 more than they normally would. So this will be gone entirely. This will be low by 1. Okay. So this still works. Can I just confirm that? The timing all still works out, yes? Well, I would never know. What? Oh, did I also not activate? Why isn't that activated? Okay, so I'll check where everything was filled, right? Let's go to position 150 again. This will make sure everything is tested against. So will this all match up now? Match? No, this is off by 2? How was it off by? Oh, because I shifted it up by 1 and I shifted it over by 1. Okay, I think we're starting to get into a bit of like this jank territory because now I'm like, the timing is very, very unstable. Well, no matter, if this is too fast, I'll just add 2 to this. 8. I don't know how much I need to add to this, but I probably don't add as much to this. I probably keep that the same because these are both yeah, okay. Ooh. So I do need to add a bit to this. So let's add 14 and then we'll add a bit more here as well. Okay. What? Oh, what? There should be a 14 out of 4. What happened there? No idea. Okay. So let's check. These all sync up. These do not sync up anymore. Okay, so this should be even further. Wow, why do I have to wait so long? Does this actually have to wait 14? This can wait one less, honestly. But I guess for parity's sake, we'll just... Okay, so that works. That times everything up. The reason why I wanted this is because I wanted space here. I wanted to add nullifiers to these guys. Okay, so how this is going to work is you will nullify the top because you're coming in last. If that's the case, can I use red wire? Yes, I think so, because this B is not going to affect this guy much. So I'm going to just use get rid of this wire, use blue wire over here to activate this nullifier. This nullifier will nullify... Wait a minute. Does it matter? Let's nullify 2, right? And this activates. And then this one will activate you. So you'll go down here and then you activate this. So these guys, wait. But see, the problem is that I want this to be activated, but this to not be activated. So rather, this should be a natural nullify by 1 on this. Yeah. So unless this is a 0, if this is a 0, this will not nullify, throwing it away. If it isn't a 0, it will nullify and it will pass through to this. Yes, okay. This is a bit more challenging. This still needs a bit more. Okay, I can make things a little easier for myself if I did. I think if I did this. I have some space. It's the same thing here, basically. And then this guy can subtract by 2, I think. So let's see if this works. So here, the nullifying should not take place. Wait, what? Wait, why doesn't nullifying take place? So the 2 is wrong. Oh, what? Oh, what? So this B activates this, yeah, sure. Oh, it will switch if... Yeah, no, we do want nullification. Nullification should be on right now because these guys will come down. So yes, these guys should be nullified. Good. So they match correctly. They match correctly. Okay, timing works out. If we went back and checked on 42, we'll see that both of these will get nullified, right? So this will activate this. This will activate this. These 2 duplicates will come out, be nullified, and get thrown away. Be not nullified and get thrown away. Yep, and that just leaves this 2. The 0s will come out, and the 0s probably can join the main parade when it should. So yes, this works. For some god knows what reason it works. Oh, wow. Yeah, sure. Okay, I'll take it. So we then want these guys to kind of come in around the same time as this comes out. We know this will always come out at a set amount of time because the top path is the timing for the top path is set and everything else is based on that top path's timing. So everything else is basically also set, meaning that now we just have to activate the movement of the pointer in accordance to this guy. Okay, so let's do a bit of checking. We know that on cycle are we on? On cycle 3, the obstructor begins. You want to know at what time, around what time does the first output come out here? The first output comes out here on cycle 35. So we waited about 32 here. The output should come out around the same time as this. Am I correct? Close enough. Good. We can tweak it if we need to. What I would like to do is, this should actually be held a bit more. Because after the output of here, right, I still have to collect all of these. And after collecting all of these, I still have to draw the color chart, which I should probably already just do, by the way. So what are the values we're looking for? We're looking for the values 1, 2, 3, 4, and then 0 and 17. Okay. If a value of... But a value of 0 will not work. A value of 0 actually won't work. Yes, a value of 0 won't work, because the value of 0 will be overridden by the 2 that compares with it. This will output a 2. Crap, that is bad. Unless we completely ignore the 22 entirely. We have something that just throws in... Or maybe we start at 19. We just skip 22. 22 will help us in no way whatsoever. 22 will only provide us with the 3 bits that are already there. It is only from 19 onwards. So maybe we start at 19. We know 19 onwards is fine, right? Let's actually check that, just to make sure. 19 should be fine. 19 will give us... Yes, okay, 19 is fine. So, okay, now we have completely skipped 22 as a step. No one needs this first bit. Doesn't help us. We only need to now check for 1, 2, 3, 4, and 17. Good. And how will we do that? Back to our color chart. Do we have space for this? I guess we might. Okay, so color chart goes output we want a conveyor that connects to a 167 definer, because the final step, the defining to be 167 has to be the last step. You can't define them at the start, because when they merge together they'll end up with different values. The colors can come from here, which for convenience sake I'll label R, G, and B. I think here's also written very yeah, it is written in order. This is R, R and G, G, G and B. And then if there were a fifth one, it would be just B itself. And there'll be a magenta somewhere for R and B, but that doesn't ever happen. So, okay. We know each of these come from their respective Ys. What do I know about the colors? What happens twice? Green happens. Yeah, green is part of... Green, it can either be its own thing or with red and with blue. So what I'll do is probably I'll set the singles to be here. This can be where the doubles come in. Okay. I literally clicked... Oh my god, I clicked Y to set this to a Y signal. That is very bad. Okay. So just to recap, a 1 will do what? A 1 will... Sorry. A value of 1 will give red. Okay? So 1 will give red. A 2 will give red and green. A 3 will give green. A 4 will give green and blue. Okay. Okay. So let's try this out. Crap, I need to see. I can't just derive this myself again. I don't have the space for it. So 1 is on you, 2 is on you and you. This is why green being in the middle felt much better. Yeah, okay. I see why I did that now. Because green is used so many times throughout all of these that it just has to be. I mean, if I wanted to save space, I can just do this. It's not much different. The wiring does get a bit awkward though. So maybe I will still do this. Okay, so there will be one of you. there'll be one of you. There'll be one of you. And there'll be one for green on its own, which is this. Okay. So yeah. And then there should be a fifth one for, you know, 170. Which should also still be timed in accordance to this, by the way, but we'll hold on to it first. This should be the last step, I think. Okay. So let's do it this way. Okay. So this should be the value of 4. The value of 3 is this, yes. The value of 2 is up here. See, the problem is that we get overlaps, which I don't like. And then the value of 1 should be elsewhere. If it's... Wait, but does it not matter? It doesn't matter, right? It doesn't, it's an equal. It doesn't matter. Yeah, it doesn't matter at all. It does not matter. I'm almost certain it does not matter. What is this? So this will be a 1 checker. That should also be a 170 checker, by the way. So actually, yeah, this is a kind of wonky already, so it's not. In fact, why don't I do this? So this is for 4, which is this and this. This can just be for either 3 on its own with a red wire, or for 2, which is all for the blue wire. Yeah, that's fine. There we go, more space. Because you just gotta make sure the colors work out properly. So I think, like, just to keep things a little nicer, 3 will be here, 4 will be here. Is this good? Yeah. I guess I can do this. There you go. 2 will be... I guess 2 will be here. Jesus. Okay, and then I guess 1 can be here. And then the 170 can come afterwards, and then it can be thrown away. Yeah, sure. Oh, 70, not 170. And then that can just, you know, magically activate itself here. This don't bother about the wire not being here. We know all this is gonna be regular conveyor belt shenanigans anyway, so it doesn't really matter. Okay. Whew. That was a lot of work. Time to time everything. Hopefully I don't need more space here. If I do need more space here, I'm a bit cooked. In fact, I think I might need more space here. Oh gosh, oh gosh, oh gosh, oh gosh. I will need a lot of space, won't I? Okay. Okay. So after some amount of time, let's go back to 42, our good old timer. 19 will come out. We'll get a certain value here. So okay, let's just have these guys wait indefinitely for us while we check on other things. The first thing that comes is this 19, which should be the one that's checked against, yeah? Okay, this should... Yeah, let's hold for a lot longer. Let's hold for 40 cycles. It's actually gonna take way longer than 40 cycles. I'll just throw you away. I wanna mess things up. Okay. So this will activate those. That will merge into yellow. And then yellow would be here, yeah. Wait, we need to check for 0 as well. Do we? Oh, we do. Crap. I realized that now. We do need to check for zeros. What does zeros even do? Zeros just get sent in. Yeah, zeros just get sent in. You just gotta wait. Okay, if zeros just get sent in, then I think our best bet is just putting this here and then waiting. Fortunately, we can duplicate outputs, so it's fine. They'll just wait until the time is right and then the pointer is in the right position. Okay, so what are we on to again? Right, I was timing this, so... Okay, can we actually figure out the exact directions that we need first? Because where will we be? We'll be here, right? We're gonna go here, then back, then back down. Wait, but how do I go to the next one? I realize that now. Like, let's say I'm done with this, right? How do I go to the next one? Because after the 17, I can't just push 4x2. That'll put you here. I'll need to do a lot more than that. What? How did... what? Yeah, I don't know about this. Okay. I think I got a lot further in terms of working out the machine. But I think I'm a bit tired now. I really don't know if I should be doing this. I'm definitely gonna need some help here. Yeah. Alright. I think this is burning me out. I think that's gonna be it for this episode. Yeah, hope you guys enjoyed this video. See you guys next time. Bye bye.